Assuming you're familiar with infrastructure as code, a good question to ask is, why bother? Why learn new languages and tools and burden yourself with additional code to manage? The answer lies in the power of code. By investing the effort to convert your manual practices into code, you unlock significant improvements in your software delivery capabilities. Recent studies highlight the impact of infrastructure as code and DevOps practices on operational efficiency. According to the 2024 State of DevOps report by Puppet, organizations using infrastructure as code experience faster deployments, with 70% reporting quicker deployment times and 65% observing improved software quality. They also achieve significant cost savings, with 60% reducing operational expenses through optimized resource use. When your infrastructure is defined as code, you are able to use a wide variety of software engineering practices to dramatically improve your software delivery process, including self-service, speed and safety, documentation, version control, validation, reuse, and of course, happiness. Let's review them a bit closer. Most teams that deploy code manually have a small number of system administrators who are the only ones who know all the magic incantations to make the deployment work. This becomes a major bottleneck as the company grows. If your infrastructure is defined in code, then the entire deployment process can be automated, and developers can roll out their deployments whenever necessary. If the deployment process is automated, it'll be significantly faster, since a computer can carry out the deployment steps far faster than a person. And safer, since an automated process will be more consistent, more repeatable, and not prone to human errors. Instead of the state of your infrastructure being locked away in a single administrator's head, you can represent the state of your infrastructure in source files that anyone can read. In other words, infrastructure as code acts as documentation, allowing everyone in the organization to understand how things work, even if the system administrator goes on vacation. Version control systems, such as Git, can be used to track changes to the infrastructure code, allowing for easier debugging and rollbacks. By storing your IAC source files in version control, you can capture the entire history of your infrastructure in the commit log, making it easier to identify and resolve issues. If the state of your infrastructure is defined in code, then for every single change, you can perform a code review, run a suite of automated tests, and pass the code through static analysis tools, applying all practices that are known to significantly reduce the chance of defects. You can package your infrastructure into reusable modules so that instead of doing every deployment for every product in every environment from scratch, you can build on top of known, documented, verified modules. There is one other very important and often overlooked reason for why you should use infrastructure as code: happiness. Deploying code and managing infrastructure manually can be a tedious and unrewarding task, taking away from the creative and challenging work that developers and system administrators enjoy. Infrastructure as code, or IAC, offers a better alternative, allowing computers to do what they do best and developers to do what they do best. By automating routine tasks, IAC can improve the overall quality of life for developers and system administrators, allowing them to focus on more creative and challenging work. Now that you understand the importance of infrastructure as code, let's take a look at one of the most popular tools, Terraform, and see if it's the right tool for your needs. To help you decide, we'll provide a brief overview of how Terraform works so you can assess if it aligns with your requirements.
Terraform is an open-source infrastructure as code tool that enables users to define and manage their cloud and on-premises infrastructure using a human-readable configuration file. Developed by HashiCorp, Terraform allows users to write infrastructure code in a high-level configuration language, which is easy to read and write. With Terraform, users can define their infrastructure resources, such as virtual machines, networks, and databases, and manage their lifecycle, including creation, updates, and deletion. Terraform supports a wide range of cloud and on-premises infrastructure providers, including Amazon Web Services, Microsoft Azure, Google Cloud Platform, and OpenStack, among others. Terraform key features include infrastructure as code, which is a way to define infrastructure resources in a human-readable configuration file. Multi-cloud support. Terraform supports a wide range of cloud and on-premises infrastructure providers. State management. Terraform manages the state of infrastructure resources, including creation, updates, and deletion. Modularity and reusability. Terraform allows users to break down infrastructure code into reusable modules. Large community. Terraform has a large and active community of users and contributors and widely used by DevOps teams and cloud engineers all around the world. Its simplicity, flexibility, and scalability make it a popular choice among organizations of all sizes. Terraform uses declarative configuration files to manage infrastructure, which means that you describe what you want your infrastructure to look like rather than how to create it. This approach is in contrast to imperative configuration, which specifies the steps to take to create the infrastructure. Using declarative configuration files with Terraform provides several benefits. For example, your infrastructure can be defined in a version-controlled configuration file, making it easier to manage and track changes. Terraform ensures that your infrastructure is consistent across environments and deployments. You can reuse Terraform configuration files across multiple projects and environments. Terraform declarative configuration files make it easy to switch between different infrastructure providers or environments. Now let's talk about how Terraform works. Terraform is an open source tool created by HashiCorp and written in the Go programming language. The Go code compiles down into a single binary called, not surprisingly, Terraform. You can use this binary to deploy infrastructure from your laptop or a build server, or just about any other computer, and you don't need to run any extra infrastructure to make that happen. That's because under the hood, the Terraform binary makes API calls on your behalf to one or more providers, such as Amazon Web Services, Azure, Google Cloud, DigitalOcean, or OpenStack. That means Terraform gets to leverage the infrastructure those providers are already running for their API servers, as well as the authentication mechanisms you're already using with those providers. How does Terraform know what API calls to make? The answer is that you create Terraform configurations, which are text files that specify what infrastructure you wish to create. These configurations are the code in infrastructure as code. Even if you've never seen Terraform code before, you shouldn't have too much trouble reading it. The example on the screen tells Terraform to make API calls to AWS to deploy a server. In just a single, simple syntax, Terraform allows you to deploy resources across multiple cloud providers. Overall, Terraform's use of declarative configuration files provides a powerful and flexible way to manage your infrastructure, making it easier to create, update, and manage your resources in a consistent and repeatable manner. Terraform enhances software delivery with faster deployments, improved security, and cost efficiency. Supported by a vast ecosystem of providers, Terraform simplifies infrastructure management, making it the ideal tool for organizations seeking to optimize their operations and scale efficiently.
As we explore the powerful capabilities of Terraform in managing infrastructure, it's important to recognize the tools that can further optimize and streamline these processes. One of such tools is TerraGrunt. It's an open source tool developed by gruntwork.io, designed as a thin wrapper around Terraform. TerraGrunt builds on Terraform's foundation, offering additional features that simplify complex configurations, reduce redundancy, and enhance scalability across multiple environments. Let's dive into how TerraGrunt takes Terraform to the next level. TerraGrunt is particularly useful in scenarios where you have multiple environments, such as development, staging, and production, or when you need to manage multiple Terraform modules across different projects. Here are some specific use cases. Multi-environment management. When you need to deploy infrastructure across several environments, TerraGrunt allows you to reuse your Terraform code without duplicating it. You can define your infrastructure once and then apply it across different environments. Remote state management. Managing Terraform's remote state can be challenging, especially in large projects. TerraGrunt simplifies this by allowing you to define your remote state configuration only once for all environments. Automation across modules. For large-scale deployments involving multiple Terraform modules, manually executing Terraform commands can be time-consuming and error-prone. TerraGrunt automates this process, allowing you to apply changes across multiple modules and environments simultaneously, improving efficiency and reducing the potential for mistakes. Environment-specific configurations. If you need to set up different configurations for different environments, such as varying provider settings or authentication mechanisms, TerraGrunt's Generate Block feature allows you to inject these custom configurations into your Terraform modules without altering the underlying code. Here's a simple example of how TerraGrunt can be used to manage Terraform configurations across different environments. In this example, the Terraform block specifies the source of the Terraform module, while the inputs block provides environment-specific variables, making it easy to switch configurations across environments. So, why use TerraGrunt? TerraGrunt enhances Terraform by making infrastructure code more maintainable, consistent, and easier to manage, particularly in complex multi-environment setups. Its ability to keep Terraform configurations in the dry manner, effectively manage remote state, and automate deployments across multiple environments makes it an invaluable tool for teams striving for scalable and reliable infrastructure management. If you're managing large-scale infrastructure, TerraGrunt can significantly streamline your workflow, reduce errors, and improve overall efficiency.
Thank you for taking the time to join us in exploring Terraform and TerraGrunt today. I hope you found the insights valuable and now have a clearer understanding of how these tools can revolutionize your approach to infrastructure management. Remember, the journey to efficient, scalable, and maintainable infrastructure doesn't end here. It's just the beginning. If you have any questions or need further assistance, feel free to reach out. Thank you once again, and happy coding!